us to divide a whole into separate parts. The denominator, D-E-N-O-M-I-N-A-T-O-R, to spell that, the denominator tells you how many parts the whole has been divided into. The numerator tells you how many of the divided parts that you have. So back in primary school, do you really need to interrupt right now? You can give me a move, sure. Back in primary school, you probably would have been used to seeing diagrams like this. Here is my pizza. I'm going to keep this simple. I'm going to cut it into 4 pieces. The 4 pieces is the number that goes on the bottom. It's that one, and it is called the denominator. If I were to choose some of those pieces, maybe I would take that one, and that one. If I take 3 of those pieces, that becomes the numerator, because I have selected 3 pieces out of the 4. Okay? The horizontal line separating the numerator and the denominator is called the... If anyone knows this word, I might have to give you a lolly. Does anyone know the name of the line? So in my fraction over here, where I have the 3 on the top and I have the 4 on the bottom, there is a special technical name, it's not just line, for the line here. That line is 3 over 4. That line there, I'll even tell you it starts with a V.
What does it start with?
A V. No, Jai. As soon as I say it, before you... Nope. No. Oh, I'm going to have to tell you, aren't I? Daniel? No, that's the point of the shape. Ronan? Come on, a V word.
What does it end with?
No. Come on, last guess. No. It's called a vinculum.
I was about to say that.
Oh, you were totally going to say that.
You should give me a lolly because I was thinking that.
You were thinking it. No. I knew that would be unlikely that anybody would know that one. So that line in our fraction is called the vinculum, and it has the same effect as if you were using the divide sign. So if I had a 12 on the top of a fraction and I had a 3 on the bottom of the fraction, it is the same as saying 12 divided by 3, which is equal to 4. Okay, so that vinculum is the same as dividing. A proper fraction is less than a whole. That means that the numerator is going to be smaller than the denominator. Okay, the one that I gave you at the top there, the 3 over the 4, that is an example of a proper fraction because the top number is smaller than the bottom. And there's another example here for you. Here is an example, 4 over 7. That is a proper fraction because the top number is smaller than the bottom number. However, not all fractions are like that. Some fractions have a bigger number on the top, and that is called an improper fraction. So that's this next one. An improper fraction is greater than a whole. That means that the numerator must be larger than the denominator. So here is an example, 10 over 7. Ferris, do you need to move away from there?
No.
You should not be talking. Don't need to use words. Get the pencil and you get writing. 10 over 7 is an example of an improper fraction. And we're going to be learning how to do this. We can change those into what are called mixed numerals, this one here. We're going to practice it more later, not in today's lesson. You work out how many 7s are in 10. So you could take one whole lot of 7 out of that, set 1. And then there'd be 3 left over, which is the one that goes on the top. Writing it in this form, you can see that it is larger than 1. You got the whole one and the 3/7 extra on top of that. Whole numbers can be expressed as fractions. Sometimes that is going to be very handy when we're adding and subtracting fractions later on. So 4/4 is equal to 1. Okay, that made a whole number. 8/4 is equal to 2. So sometimes our fractions can become whole numbers. Any fraction with a denominator of 1 is equal to whatever the numerator is. So 6/1, we can simply write that as 6 because 6 divided by 1 is just 6. Okay? All right, that's the theory bit. Yep. On the next page, we have an example. Example number 1, there's our lovely little pizza diagram there. Part A, how many pieces has the whole pizza been divided up into? That's how many in total. 1, 2, 3, 4, 5, 6, 7, 8 pieces when I go around and count them all up. There are 8. Wait, I'll change my pen back. There are 8 pieces that I have divided that shape up into. Part B says, how many pieces have been selected? In other words, the shaded ones. Ferris, pick up your things and move. You've got no excuse whatsoever to be talking now. The shaded ones, there are 3. Now, I could have asked that question in a different way. So here it is again. This is actually asking the exact same thing. What must be the denominator? If I'm going to make that into a fraction, Stella, that 8. The total number of pieces in that pizza, that is going to be the denominator. What must be the numerator?
3.
Yes, Poppy? 3, because they're the ones that I've selected. I want 3 of them. Then I can write that as a fraction. The numerator obviously has to go on the top and the denominator goes on the bottom. And our new favourite word, vinculum, is the line in between. All right, question 2. Represent 3/5 and 9/5 on a number line. We did a little bit of work with number lines in our last topic. This is going to be a little bit different. We're not just going to show those numbers. We need to show roughly where they would be placed in respect with other numbers on there. So it's pretty hard to show, if I was only using my whole numbers, my integers, it's pretty hard to mark 3/5 and 9/5 on there. So you can actually make your number line go up by fifths because that's the denominator that I've been given. So with your ruler, you want to measure spaces. You should always measure the spaces on your number line. I'm going to use about 1 centimetre.
How many numbers are we going?
Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I did 11.
11.
Yeah. You've got a fairly long line there, so let's put lots of spaces on there. Ooh, slack. So you need to have a way to have your rule. I know the rulers are a bit of a pain because they don't fit in laptop cases and things so well, but you need one. So even if you, I know this big massive one, you can get yourself a smaller little plastic one and then they fit in.
I don't know where that was. Thank you. I got this.
I'm looking at Ronan. I don't need you to ask the question. I know what it is. Whoa! There's more. Slackers!
I didn't take my computer, which
Slackers.
has my rulers. The only time.
We might have to do some sharing. I don't have rules for everybody. Can you share with me? So I can this one too.
Oh, okay.
Can you share?
Oh,
Alright. Now I'm going to start from 0 because a 0 seems like a good place to start. If I'm counting in fifths, so each one of those lines is going to be going up by 1/5. So the 1/5 would be the first line. 2/5 for the second one. 3/5. 4/5. The next one would be 5/5. What's a better way to write 5/5? 1 whole. Good. Then after 5/5, I need to go back to my fifths again. 6/5. Yes, I'm going improper. 7/5. 8/5. 9/5. And instead of 10 fifths would be 2. Okay, so that gave me all the way from 0 to 2 with all my little fifths in between. So now I can mark, and you use a dot. I'm going to use my orange pencil.
I just circled it.
I want to represent 3 fifths. So at the 3 fifths, we put a dot sitting above that number line. That's how I show it. That's the one that I want. And 9 fifths, I put a dot above that one. Okay, so that's it. We just want to show that's where those two values would be on that number line. Yes, you do, because we didn't want, although we needed the other ones to have a scale there, we only want to represent, those were the main two we wanted to show. No, please put a dot.
Can I fit 3 in because I slightly skipped 3?